So this lecture video is going to cover the process of integration by parts. And so we'll start by just remembering the relationship between differentiation and integration. And in fact, these processes are what we call inverse processes, which means that they reverse one another. And in the same way, we can think of one of our known differentiation rules from way back, the product rule, and this new thing, integration by parts. In fact, these two processes are inverses of one another. They cancel each other out, or they reverse one another. And so if we start by looking at the product rule, we have a function f and a function g being multiplied, and we're going to take the derivative of that product. And so if we have the derivative of f times g, we get f prime times g plus f times g prime. And that's the product rule. And so we'll just rewrite it here a little bit. Instead of writing it with f and g, we're going to write it with u and v, and we're going to take the derivative with respect to x. So we take the derivative with respect to x of u times v, and that's equal to u times dv dx plus v times du dx. So once again, this is just the product rule written in a slightly different way. And so we're going to do some algebra to this. And what we're going to do is subtract u dv dx from each side. And so we end up with u dv dx on the left side with a minus sign, and v du dx by itself on the right side. Now we can take the integral of each side, so the integral with respect to x on each side. And remember, we take the integral of the entire side. And so first on the left, what we're going to do is, because there's a minus sign in between, we can break it apart into two separate integrals. So the integral of 1 minus another integral equals this integral here. And now, with that, we can actually cancel out all the dx's, cancel each other out. And on the very left here, this integral and this d that's just by itself, they cancel each other out as well. And so what we get is this form here. It's the product rule, but it's rewritten in integration form. And so we have uv minus the integral of u dv equals the integral of v du. And you might also see this as uv minus the integral of v du equals the integral of u dv. And please note they're equivalent, so it doesn't really matter which form you use. Whatever's written in your textbook or whatever notes you're using, they're the same. And so basically now, the idea is, with this form, this integral of v du is the integral that we want to solve. And typically, we're going to be given a difficult integral, and we don't know how to solve it quite directly in this form. And so what we're going to do is we're going to somehow use this, we're going to somehow rewrite it in this form here, and hopefully this is a little easier to solve. And in order to do that, we have to identify whatever function we're given to integrate. We have to identify a part of it to be v, and we have to identify a part of it to be du. And from there, we can take v, and we can get the derivative to get dv. And we can take du, and get the integral to get u. So we'll end up with u, v, du, and dv. We'll get four pieces, all from this integral v du. So from v, we find v and dv, and from du, we start with du and we eventually get u. And so once we have all four of these pieces, we can take them and plug them in here. We can plug in u, we can plug in v, we can plug in u, and we can plug in dv. And again, this is the integral we want to solve, but it's going to be something difficult and something we can't just do. And so if we identify u and v and du and dv, then we can go ahead and rewrite this scary integral in this form, which is going to be easier, at least hopefully it's easier, to solve. If it doesn't get easier, please note that that means you might, one, need to be a little more creative with your integration by parts, and we'll talk about that a little more later. Or secondly, it might just mean that you chose the wrong v and the wrong du. You want to make things become simpler in the end. If it gets more complicated, then you've gone the wrong way.